Okay, so my name is Maxwell Kendall. I am the proud leader of Meadow Balloon Society, which is a small Discord group. And today I'm going to be explaining why we're here and what this is and what everything on this table is. So first things first. So it all started out when I launched my first weather balloon. It was quite a while ago in March, in fall. So basically a weather balloon is a big balloon like this, then a parachute like this, and then a parachute. The payload. The payload is where all the electronics and software is uploaded and created. For example, this is the payload of my real weather balloon. The second one. So, the first weather balloon, the payload consisted of a small microcomputer called a Raspberry Pi, a Pi camera, which is a camera controlled by a Raspberry Pi. This is an example. And a GPS tracker, just a regular old GPS tracker, nothing special about it. The size of like this big to track phones, basically. So, once I got the program uploaded on the Raspberry Pi to control the camera, I then mounted it in the payload box, which can be made of styrofoam or cardboard. I made mine out of styrofoam, and so will this one. And it didn't work. So at launch day, it was a sunny day, and the wind was high, and we got regular old party helium, like the one over there. So the thing about that is that it's not pure helium. It's only 80% helium or less. So there's also that extra 20 or 30% air. And that does not make a good mix with high altitude balloons. High altitude balloons need pure helium, and they usually come in big places such as welding supply stores such as Airgas. Now, the thing was, we bought 3 of those small helium tanks, balloon time, and that wasn't enough. There was supposed to be some number of cubic feet of helium in the balloon, and it's smaller than this one, much smaller, about halfway smaller. But there wasn't enough helium, and we needed 1 extra tank. So my dad and my sister had to run out to the nearest Target or Walmart and get party helium, and then run back, and by then we were 30 minutes late or more, late for the launch. And the helium, even then, wasn't enough to lift the balloon. So the GPS tracker, once it actually did go up, once the helium worked out, so it flew up, and the regular cell phone GPS tracker, so GPS trackers are not reliable. They have to face exactly up at the satellites, and they only have very limited battery power. So this one ran out of battery power and failed miserably 9 minutes into flight. And so now what I'm doing for my second weather balloon is a much more high-tech technology. So the biggest improvement is my tracker. This uses APRS, which is a better method of tracking. So it uses ham radio, which you can talk to people using this. And so a tracker that looks like this in the beginning, so we're using that for the radio transmitter. And with the GPS antenna attached, this one has to be facing the satellites, but that's not that big of a deal. But now, after many months of debugging, we came up with this design. So this is a buzzer, which sounds when it's below a certain height. And then there's a radio transmitter, and then there will be a GPS antenna attached. Now this hopefully will be much more reliable. In fact, I did a big test yesterday at Blue Hill in Walpole, and everything there worked with the tracking. And I forgot to mention, for the second weather balloon, I'm also using a sensor, which measures temperature, pressure, and altitude. And I'm annotating that or writing it to the screen of the video recording, so that when people see it, it will be automatically on the video. So we're planning on launching this in about a week or so. And so a prediction software is what we will be using to predict where it will land on a certain date or time. So for example, this is today at 9 minutes ago. This is a prediction at Choate Park. And if you put in all the variables of the flight, it could end up in Marshfield. Now, of course, it can be 5 miles off. So it could end up in the Pacific Ocean. It could end up on Hawaii. No one knows. But this basically gives a general idea of where it's going to land at what time and what day and where. So to track the balloon, I'm using two things. One is a website called Google APRS.FI, which lets you track a balloon. So my call sign, which is my identificator, is W0MXX. Now -11 means a balloon, and it is a weather balloon. So I'm using -11, and it's automatically coming up as a balloon, because it's -11. So if you see the raw packets, which is what it's decoding from the signal, it shows, W0MXX-11, the way I'm transmitting the APRS packets, then all the information that I can customize. So it transmits 1 minute in 1 minute intervals, and I can program in my radio to the frequency that I want. So it should transmit soon. And you should hear something like, and it will sound pretty weird. I probably just missed the transmission, but actually I can check what time it is. So it should transmit in 30 seconds, but meanwhile, so this is my SDR radio, which can be plugged into the computer. And instead of using this, I can hook it up to the computer, pipe it into a software called HDSDR. There are other SDR softwares, but this is what I prefer because it's the easiest to use. This is about to transmit a packet. And that's what it sounds like. So that's basically the tech I'm using for my second weather balloon. So the way a weather balloon will float up, can someone give me scissors? Okay, so the way a balloon flies up is when you launch it, it floats up higher and higher, then once a pin, and then the balloon will pop due to low pressure at higher altitudes because the balloon will expand, and it can go up to 8 feet depending on what the size of your balloon is. And then it will fly up and higher, and then it will pop. And then the parachute will open and it will float down safely with the parachute. So that's basically the basics of a weather balloon. Are there any questions? I guess that's a no. What?
So you're able to retrieve it using the GPS, is that right?
What?
Once it pops, you use the GPS to retrieve the weather balloon?
Yeah, so you basically chase it down. So it's going to be about 100,000 feet in the air. So you won't be able to see it. It's not like chasing someone. So it will be very high up. Then it will float down on the parachute. And then you can track it to see where it's exactly going. And then using that GPS information, you can locate where it is. Aiden, do you have a question?
Yeah, what happens if it lands very far away from you? What will you do?
So what if it lands super far away from where it says it is? So the prediction software, such as predict.habhub.org, it will basically predict where the balloon will land using the wind data and many other factors. It's a very amazing website. I can show you privately. But if it lands very far, you can combine where it's saying it is with where the prediction will be, and then use those two, whatever it's called, to pinpoint where the balloon is. Amir, do you have a question?
Where's the farthest it can go?
It can. So the furthest it went was from Connecticut to Maine, and that's basically so basically it can travel very far depending on the wind, and it will stay up longer and higher if you use less helium, because it more slowly goes up, which means it stays up higher so that it has more chance of getting further. Are there any more questions? Sam?
What happens if it lands in the water? Will it kind of damage the software and stuff?
Yes. Aiden?
I forgot what I was doing.
Okay, it's fine. Amir?
So is there anything to protect the software if it lands in the water?
Yes. You can use certain types, so you can water insulate the software. You can use foam, spray foam, and many other things like that to waterproof the electronics. Any more questions? Oh, yeah. So if you want, I'll show you what the electronics on the printer looks like. So this is my APRS tracker with the GPS antenna, and this is my Raspberry Pi with the Pi camera right here, and my sensor detecting temperature, altitude, and pressure.
What's the most fun part of the project for you?
It is probably going through thousands of errors. Anyone else have a question? Aiden?
I just wanted to ask, what is your favorite part about building it?
Oh, my favorite part about building it? Favorite part about building it is probably wiring it up for the first time, making the first revisions of the electronics and software. Mia?
When are we going to put the real one up in the sky?
So I will get that using predictions from predict.habhub.org. And so it's still unknown. It will probably be at least a week from today. And we will put out the information once we get a final prediction, if anyone wants to come there to the launch.
Medway Balloon Society?
The Medway Balloon Society is a Discord group that you can join by going to medwaylib.org and emailing Diane and asking for the Discord link. Discord is basically a website or application to chat with people. You can make servers, channels, things like that, and different like perks you can chat. And Medway Balloon Society is basically a big server. In fact, Nathan and Arnav are in the Medway Balloon Society.
Tell us about the future of the Medway Balloon Society.
So, the future of the Medway Balloon Society is a pretty easy question to answer. We probably will be in the makerspace, which the makerspace is a room of the Medway Public Library. Thank Diane. So, yeah.
What will you do?
We will be collaboratively building weather balloon payloads and coding them.
How did you get interested in this?
Sorry, what?
How did you come to be interested in this?
Okay, so it all began when I got oral surgery at Tufts Medical Center. So my mom's friend, Gail, she gave me 2 party balloons, one for me, one for my sister, and I wanted to see how much it could lift. So I started attaching paper clips and more paper clips until it could not lift anymore. So I will not give away my results because that's why there are paper clips and balloons over the tables.